My name is Sean Smith. I'm a market development manager with New Millennium Building Systems. We're the second largest steel deck and joist manufacturer in the United States. Today's presentation is called Learning Environments. Well, we will go over primarily the use of deck of different types in schools, aquatic centers, safe rooms, and dormitories, all kind of involved in the education sector of our market and higher learning education as well. And this course is AIA HSW accredited. On this slide here, you'll see our course provider number as well as our course number, which is 2036. We have 4 learning objectives for this course. The first is to recognize the importance of acoustics in various educational spaces, meeting aesthetics with span and accessories of architectural deck. High-performance coating systems and substrate selection for corrosive environments for pools and canopies. Structural steel options and design considerations for compliant safe rooms and storm shelters. Then economical and efficient approaches utilizing long span composite deck for dormitories. Our course chapters are indoor learning environments, an overview of those, natatoriums, safe rooms and storm shelters, and then dormitories. And then we have a brief conclusion. So we'll be referring to buildings shown on this bird's eye view of a campus. We have a high-rise dormitory. We have various educational buildings, natatorium buildings, and library spaces and such. So a brief overview of what you'll be seeing in this presentation. You'll be seeing a lot of photographs of deck installed in various building types. We have N deck and B deck, acoustical versions of these decks, cellular and cellular acoustical versions. And roof deck does have a high strength to weight ratio, and it's exceptionally durable. And it does have a functional as well as aesthetic benefit to it as well. We'll also be talking about composite floor deck. Composite action is achieved through the bonding of the concrete to the deck through embossments on the sides of the flutes of the deck. I'll talk about concrete cover over fire rating and vibration control, options and cellular profiles as well. We can create a cellular composite floor deck and make it acoustical as well if you'd like to combine acoustics of a ceiling attribute to the underside of your composite floor deck. We also will show many photographs of dovetail deck. Now, dovetail deck typically comes in 2 and 3.5 inch profile heights. There's also a 6.5 inch version as well, and it's ideal for exposed ceiling applications. We've seen dovetail acoustical deck used in libraries because of the high NRC value you can get with this, as high as a 1.0 NRC. That's noise reduction coefficient. Also, it can be field painted or factory painted as well, factory finished. Gives a smooth plank look. And then the deep rib profiles you'll also see in this presentation. There are composite versions of deep rib as well as dovetail the deck that are available, and you'll see that in the presentation as well. With the deep rib profiles, you can have very long spans, up to 30 feet. It can have a very deep fluted industrial look aesthetic, or you can cover it with a liner panel and perforate for acoustics. This also has a very high NRC value, as high as a 1.0 NRC, noise reduction coefficient. We've seen this used in schools and also, going off topic slightly, airports, other large civic projects, transportation centers across the country. And a really quick overview here, touching on joist that are available in the marketplace. When you are coordinating with your structural engineer, I'm sure you've probably seen K and LH series joist, possibly DLH as well. We like to refer to these as small, medium, and large. You have the K series joist for shorter spans, LH for longer spans, and DLH for quite a bit longer spans, over 100 feet. We have composite joists available as well. That's a joist used in conjunction with a composite floor deck. Use a joist in place of a wide flange beam. There's also specialty joist available. We have scissor, gable, bowstring, and arched joist, which help to contribute a lot also to the architectural look of your building, interior and exterior wise. Now we're going to look at indoor learning environments. So there's many types of learning environments that you might be exposing your deck on a project. We have classrooms, common space, computing, laboratory and vocational spaces, libraries, cafeterias, multi-purpose, gymnasiums and pools, performance and auditorium areas, dormitories, that would be a long span composite deck, connectors and hallways, exterior canopies as well. I'd also like to mention storm shelters. It's not shown on this list, but it is part of this presentation, a large chapter in it. Now looking at what sound is, noise would be unwanted sounds from adjacent spaces, reverberation from surfaces, structure-borne sound, and reflected sound. So there's many ways to help absorb sound within a space, and one of them would be incorporating an acoustical roof deck into your project. Anytime you have an exposed deck that has a flat bottom side to it that's not fluted, like a dovetail deck or a cellular deck with a liner panel, you're going to absorb a lot more sound than just a perforated fluted deck such as a B or an N-type profile. But good acoustics will enable intelligible speech, privacy, minimize distractions, and sound quality. Like I've said, we have seen the acoustical deck used in not only cafeterias, as shown in this photograph here on this page, but also library spaces and classrooms. So looking at how sound is measured in our places of learning and also in other building types, we have NRC, that's noise reduction coefficient, STC, sound transmission class, and IIC, impact isolation class. The latter two correspond to, in our case, separating vertical spaces with composite floor decking. So NRC per ASTM C423 measure is a measure for rating overall sound absorption when in an architectural space where the sound is being reflected at many angles of incidence. So you can see on the diagrams on the right-hand side, the red lines represent sound reverberating, bouncing around within a space. And then we also have a photograph of a copy machine, and those can make quite a bit of sound too. So we're trying to mitigate that sound within a space and within a learning environment, within an office, etc. So reverberation is a sound within a space of a building up due to repeated sound reflections off the surfaces of a room. There's different ways to absorb sound besides using an acoustical deck. You can use a drop ceiling, but one of the purposes of using an acoustical deck is eliminating materials. So you're integrating that secondary ceiling system into your deck. You're exposing your deck elements for a more open look. Also, with the longer spanning types of deck, such as a dovetail or a deep rib deck, you can eliminate some joists as well. If you happen to use a little bit deeper joist, you can space them out further as well. So that would mean less tonnage with joist. Overall, less materials means less construction waste. So not only is there a financial benefit to using less materials, there's also a sustainability benefit as well. Besides steel having a very high recycled content and many steel manufacturers having updated their EPDs, environmental product declaration reports, still reducing products means reducing your footprint as well, your carbon footprint. We're going to look closely here at some projects using gyms using projects, I should say, sorry, using different types of deck. So here we have a gymnasium, and gymnasiums can be echo chambers, basically. This is a Legacy High School. But they decided to use a dovetail deck, so they're absorbing quite a bit of sound here. The range for a dovetail deck based on manufacturers can go anywhere from a 0.9 to 1.0 NRC. This appears to be a 3.5-inch profile. So with that, you can space your joist or joist girders, in this case, out a little bit further. That's eliminating some tonnage and helping to open that ceiling space up a little bit more. This is T.C. Williams High School. This is in Virginia. This is a dovetail acoustical deck. It has to be painted a shade of blue. We can, as in the industry, factory finish your deck for you. Oftentimes, the deck is painted in the field to match the surrounding structure, but we do color matching. So whatever, if you want your deck factory finished, you would just simply list the manufacturer as that you would have a basis of design and the color you selected, and we'd match it accordingly, just as if you're going to Home Depot or Lowe's, asking them to match a swatch of color for paint that you have in hand. This is Glendale Community College North in the Phoenix, Arizona area. This is using a deep fluted, deep ribbed, long span deck. Some of the eaves were cantilevered, and it also provided some transitions from acoustical to non-acoustical. Deck manufacturers can stop and start the pen settings, which create the perforations on a span of deck. So you could have a section of deck that is acoustical and a section that is non-acoustical as well. This is Irvington High School, utilizing a dovetail acoustical that also happens to be a dovetail composite acoustical on the floor below the image that is shown here. This happens to have an epoxy polyester coating, which is a higher level of finish for protecting your deck. Then moving on to natatoriums. Natatoriums require a little bit more attention when it comes to the paint finish, as well as protecting the insulation that is in it from moisture. So we'll talk a little bit more about that here. So here we have the Republic Bank Foundation YMCA in Louisville, Kentucky, the West Side Natatorium in El Paso, Texas. Both of these ones, again, are utilizing the dovetail acoustical deck. You could have used a regular B or an acoustical deck here as well, or perhaps a type of cellular deck. The insulation that's inside it in these applications will need to be sealed. So that's sealed, encapsulated, PVC wrapped. That's some of the terminology you might see in your spec. We as a manufacturer, if we see a natatorium project, we're going to go ahead and grab the right insulation for you that's wrapped. Side note on the insulation that's acoustical and deck can also be formaldehyde free as well. And sometimes it can come in various colors, so it's more disguised and better disguised, I should say, when you're looking at the underside of your deck through the perforations. So it can come in a variety of colors. Also, the wrap can be either clear or a black plastic as well. But the deck itself needs to have, in these applications where there's quite a bit of moisture, it needs to have at least a G90 galvanization level. Typically, you'll see deck with a G30 or G60, but here we want a heavier zinc coating, which is applied to the coil, which the deck is rolled from. So a thicker, heavier amount of zinc is applied into the G90 galvanization level for deck. Also, the paint solutions for applications such as this need to be more aggressive. So you start with a primer as your base. That could be either factory or field applied over your G90 deck. And then a minimum of a 2-coat paint solution, or as high as a 3-coat paint solution. The more coats of paint and finish you put on it, the longer it's going to last. We've had quite a bit of luck with a 3-coat paint solution. There's various types of paints and different combinations that can be used, even dry fall paints. But the more aggressive the paint finish, the longer it's going to last. So in our experience, having that 3-coat system is going to last at least 30 years, if not longer. And here's another photograph of an aquatic center, an auditorium for Northern Arizona University. As I had mentioned, G90 galvanization level, PVC wrapped, encapsulated or sealed bats. They happen to use shot pin connections for attaching the deck to the joist on this project. And once again, this is an interior and aggressive environment, so making sure you have a good durable paint system is key. We would recommend not adding a drop ceiling, such as what's shown on the left-hand side, to an auditorium. But that's not a long-lasting solution. On the right-hand side, we do have deck shown again. Whether it's deck or an exposed concrete, making sure that it is coated with a good coating solution is key to the longevity of the deck or the concrete. Also making sure your HVAC system is properly commissioned, so the atmosphere, the air within the space is not overburdened with moisture, so there isn't moisture condensing and dripping off of the ceiling. So there are a couple ways which we will finish deck for you in the factory. There's a coil-coated method and the spray-applied method. So I'll start with the spray-applied method first. That's occurs when the deck is completely rolled into shape, whatever profile it is, whether it's a B deck, an N deck, a deep rib, a dovetail deck, and perforated for acoustics if need be. And then the deck then goes bisection through a spray booth in the factory and gets spray painted. So there's paint that is added to the top, the back side. The perforated holes get coated with paint. So you have a good, all the edges get covered. So you have a good barrier to corrosion and rusting and such. In the coil coated process, they coat the coil, which the deck is rolled from first, with a primer coat and with finish coats. Then if it's going to be an acoustical deck, they will perforate it and roll it into the deck shape. The problem with a coil-coated deck is the perforation goes on after the paint has been applied through the coil coating process. So if you're using a coil-coated finish, make sure it is not on a perforated deck in an auditorium or over an eave or soffit, a sunshade condition outside, because those holes will rust, those perforations will rust. So for auditoriums, for deck used outside, we'd recommend that it's perforated, a spray applied finish in the factory or the field. We do have water based and oil based primers now. Some are water based in our industry. The application exposure your deck is going to receive is going to dictate which type of paint finish you use. Once again, highly corrosive environments, 2 or 3-coat paint systems, direct exposure to the sun, you're going to be looking at a PVDF finish. Coating thickness is a lot more easily controlled in the factory, so you get a very even finish and fewer mils of paint. Field painting can turn out well. But if you have an inexperienced painter, there can be skips, just like you see skips in areas that are left off on walls when you go do a punch list. The same obviously can occur on a ceiling application. Or perhaps the spray applicator could get a little heavy-handed and linger too long and possibly cause some drips and some inconsistencies in the finish of the way the paint looks. I also mentioned color matching at the beginning of the presentation. Color matching is something that we do within the factory. If you choose to have your deck completely factory finished, we could match the paint to the color and the manufacturer you've called out in your spec. And I would put that right in Division 5. I wouldn't go to Division 9. I try to keep it right there centralized in your Division 5 deck spec. If you have any special attachments, they're going to be used in conjunction with your deck, such as a wedge anchor for a dovetail profile. I'd list that there. I'd list whether your insulation is sealed, if you want formaldehyde free, the paint finishes. I'd put it all in a centralized area of your spec. That way, everyone bidding on it, including ourselves, won't miss it. And going from non-aggressive to more aggressive, the least aggressive finish would be a primer. Now, primers, expanding on this a little bit more, come in white and gray colors primarily. Gray primers tend to be a weldable primer, meaning that if you have a cellular deck and you want it all pre-primed, we will put a gray weldable primer on the fluted portion and a gray weldable primer on the liner, and then we'll weld through it. Or if your deck is going to be welded to a structure in the field, we would put a gray weldable primer on it for you in the factory. But most of the time, we see specs calling out for a white bottom primer or G30 or G60 deck. Now, a two-coat system, we would call that more of an intermediate finish, which can last quite a bit. Some examples of that second coat would be an acrylic top coat or a polyamide epoxy over epoxy primer, or a primer that works well in conjunction with the acrylic or the epoxy primer, for example. A three-coat system would be a finish coat such as a PVDF finish or an aliphatic polyurethane. Finishes such as those can last 30 years or greater. Now, this is a courtesy of PPG at their Fort Lauderdale test site. So companies such as PPG, Tnemec, they do testing on paints on metal substrates to see which will last the longest. And in Florida, you have UV a lot more than you do in the Midwest. For longer periods of time, you have a lot greater humidity all year long. You also have salt in the atmosphere, especially near the ocean. So those help dictate which types of paint finishes PPG or others would recommend we use on our deck. And then in turn, we recommend that to the architect or engineer. So in conclusion, with natatorium pool applications for deck, we recommend a 3-part paint coating solution for pool environments. There are a number of ways to achieve a high performance coating. You can use a bare deck galvanized with 2 coats of a Tnemec, for example, or others, Tnemec 115. Deck with a factory applied primer, and an intermediate coat, and then a top coat applied in the field. Often, this is what is done. It's applied in the field, but it is open, for the manufacturer to apply all finishes as well for you. A deck with factory applied Tnemec primer of TN 161, and a top coat applied in the field, or something compliant to that. Deck with a factory applied Tnemec finish or a 3-coat factory finish as well. We just happen to work with that company a lot over time, but there are equivalents with PPG and other companies, so you can get a competitive bid. I would ask your deck manufacturer perhaps to help you write the spec so they can make it a generic open spec by calling out the actual finish type, such as aliphatic polyurethane, PVDF, and such. And additional conclusions on pools, things that you might want to consider that will help influence your decision on what you're going to do paint wise. What are the bearing members? Are they wide flange steel beams, steel joist, or others? Does the structural engineer prefer welds or to shot pins to structural bearing members? Since the deck is acoustical, we suggest the poly-encapsulated bats and factory applied primers to handle ambient moisture. And don't forget, I didn't mention this yet, the mesh spacers to allow for airflow. The mesh is a kind of a thin plastic flexible material, crosshatch appearance. It goes in between the insulation and the bottom portion of a dovetail deck or the bottom portion of a cell deck. Now in cellular deck, the insulation, that plastic mesh spacer, will come pre-inserted. However, when you have a dovetail deck specified, the insulation and the plastic mesh will come separately, so they'll have to be laid down in the field. But don't let the installer forget to put that plastic mesh in. If it's not put in place and the insulation is resting directly on the dovetail deck, and you go to field paint, you're going to glue your insulation to your deck. So this plastic mesh spacer is a critical item, and it will come from the deck manufacturer without really being noted. But if you want to go ahead and note to allow that in your spec, go right ahead. So moving on to safe rooms and storm shelters. So tornadoes and hurricanes, excuse me, are some of the most destructive forces in nature. And unfortunately, these types of storms continue to cause injury and death to people who are unable to safely evacuate to find shelter from these events. And there has been an uptick in recent years of tornado and hurricane events, and I know we're all painfully aware of this. Some of the major tornado and hurricane events that we all probably collectively recall are Moore, Oklahoma, Joplin, Missouri, Tuscaloosa, Alabama, Greensburg, Kansas, Moore, Oklahoma, and then Hurricane Harvey, Maria, Irma, Katrina, Ike, several this year as well. Typical tornado damage descriptions from one and two family dwellings and their corresponding intensity according to the EF scale. And I'm sure a lot of us are familiar with this, going from EF0 all the way up to EF4 and then EF5. The EF5 would be total destruction, and we've seen that all too often occur. Typical hurricane damage descriptions for one and two family dwellings, corresponding to tendency in intensity according to the Saffir-Simpson Hurricane Wind Index. Excuse me, and scale. Going from category 1 up to category 5 or higher, wind speeds from 96 to 110 miles an hour all the way up to 157 and beyond. I know we've seen higher than 157 in hurricanes in recent years. Guidelines for designing storm shelters include safe rooms for tornadoes and hurricanes from FEMA, ICC 500 2014, Standard for Design and Construction of Storm Shelters, and IBC International Building Code 2018. Some additional codes and guidelines taking shelter from the storm from FEMA. Design Guide 35 for steel frame storm shelters, and the next one is minimum design loads for buildings and other structures by ASCE. So looking at IBC 423 for storm shelters, according to the code, must include storm shelter constructed in accordance with ICC 500 when located in 250 mile per hour wind speed zones for tornadoes. 911 call stations must have them. Emergency operations centers must have them. Fire rescue ambulance stations, police stations, and K through 12 school buildings with a capacity of 50 or more occupants with certain expectations if receiving federal monies designed as a safe room in accordance to FEMA 361. On the right-hand side, we have a dovetail composite deck on top of composite joist used as a storm shelter lid. So storm shelter lids can be comprised of a composite floor deck on beams or joist in place of just a concrete lid that's reinforced as well. Now, continued here on the life, safety, and health requirements. Above a 500-year flood elevation or coastal hazard area, there's a minimum of 5 square feet for tornadoes, 20 square foot per person for hurricanes. You're going to need a 2-hour fire rated separation, accessibility, means of egress, storm restroom facilities, that is ventilation and mechanical systems, doors, windows, openings, standby power, lighting, signage, and first aid kits. On the right hand side of the screen, we have a table that's showing the occupant density for these community shelters. For hurricanes, a greater square footage and area per person is needed. For example, a wheelchair area in a tornado shelter needs 10 square feet versus in a hurricane, you'll need 20. So hurricane shelters will tend to be larger than tornado shelters based on the number of occupants as well. And then looking at location options for safe rooms. First of all, they're usually a multi-use space. They're not just solely dedicated for that. So they will try to incorporate gymnasiums, locker rooms, and classrooms. I've seen plans for classrooms that are for special needs students where the entire school will gather instead of having to move those students in the event of a storm, deadly storm event such as a tornado or hurricane. But classrooms and gymnasiums and locker rooms are typical. The travel distance needs to be about 1,000 square feet from the exterior door occupancy. Group A3, 50 or greater occupants. Group B and Group E are daycare facilities, 50 or less. Locations for storm shelters. They tend to be in the central part of a building, so there is sacrificial building surrounding it for further protection. Here's an example of that. The shaded area in the middle is the storm shelter area in the school. And then here we have storm shelter located near the end, but there still is building surrounding it on about 3 sides. Looking at structural design criteria for storm shelters, you have a roof live load per ICC 303 for tornadoes of 100 pounds per square foot, hurricanes 50 pounds per square foot, wind loads per ICC 304 up to 250 miles per hour wind speed for tornadoes, debris hazards ICC 305 for missile impact criteria, lay down and falling debris, an impact factor of 2, the wave for the weight of the debris, and then this is also applied simultaneously with the live load. And looking at the tornado area, I know sometimes Tornado Alley kind of shifts, it seems like every few years, but it's pretty much in the central interior part of the country, from the upper Midwest down to almost the Gulf Coast. That's where the maximum wind speeds can be found. Then looking at wind-borne debris, and we have gone through testing in the deck industry with using our deck and our composite deck and these applications. But wind-borne debris is for the impact and pressure testing that should be conducted in accordance with the provisions of Chapter 8 in ICC 500. FEMA does not recommend any additional criteria. Categories observed or damage designated in classification. This allows for qualitative design or defined test and results: perforation, dislodgement, disengagement of fasteners, spall, permanent deformation. Missile impact testing. In the deck industry, we've worked with Texas Tech University to do this. Facilities that were used were developed with funds from the state and from FEMA. And this procedure launches a board at a test assembly to simulate wind-borne air debris. So for tornadoes, they used 15-pound 2x4, and hurricanes, and 9-pound 2x4. A multitude of assemblies have been tested to date. So in the deck industry, we've used heavy gauge B deck. We've used deep rib profiles, cellular deck, and usually the heavier the gauge, of course, the thicker the deck that is, as well as the depth of the profile and the more rigid profiles, obviously would resist these impacts much more easily than a lighter gauge, shallower profile. And looking again at structural design criteria here, FEMA rated doors and windows minimize penetrations in the roof and roof and the envelope. Other things to look at are openings, create an alcove or baffled entry sequence that uses walls as barriers to shield from windborne debris along with circulation paths and egress. And that's what's shown here on the right-hand side. We have a baffled entry. So the debris would go into that and then hopefully not go into, but if it does, it would reflect and bounce around and not go directly into the protected area. So you have a little bit of a baffle or a barrier there. So that would be a good design aspect to add to your safe room as well. Fenestration, how that is designed for your building could have a positive impact as well. Impact resistant glazing like laminated glass or polycarbonate material, then impact protective impact protective items that include storm shelters, screens, and typical mounted exterior items. So here we have an example of windows with storm shutters on them that close from the inside in a safe room. And the windows are not large either, so we're limiting, I should say, the size of window openings. And then we have the shutter there that's added to it. And this is all in conjunction with our aspect of it, which would be some type of composite roof deck system. Anchorage and connections for load path. It's going to vary based on materials, but with a roof deck slab connection, you'll have different details for that for joist and beams. Connection of joist and beams to walls can vary. There could be a plate anchored to the wall for studs and reinforcement, wall connections to foundations, and foundation to soil that completes a continuous load path. So here on the right-hand side, we have some details that have been involved in storm shelter design. You'll see on the left-hand side, a dovetail composite deck with reinforcement going into a granite wall. And on the right-hand side, you have a standard composite floor deck with reinforcement bars going into a granite wall as well. And then you have this granite concrete block wall that's sitting on a footing and foundation, and it's attached that way with rebar as well. So the idea is just creating a very tight box and lid that's stout and resistant to wind loading, debris, wind pressures, etc. So there's different material options, and we'll just go over everything in addition to the steel components that can be used. But concrete, cast in place concrete and precast concrete, reinforced walls, they need to be at least 6 inches thick. Tilt-up wall panels or insulated concrete form concrete form reinforced with no discontinuities. That is. Composite deck, roof assembly, or precast products. These can be exceptional impact. They can provide exceptional impact protection. That is, wall heights are achievable. Limited design flexibility, but they can be heavy and the most expensive. Reinforcement considerations need to be had. It does give a bunker-like appearance when cast in place is used. Concrete block or concrete masonry unit, CMU, that is reinforced with concrete and rebar in every cell. Needs to be at least 8-inch thick CMU, is what's most used, I should say, with other assemblies that have been tested. Brick only has been tested as a veneer. So that would just be a veneer. It would not be anything structural in this case. Typically, this pairs with composite deck, roof deck that is, or a precast product. So this will provide exceptional impact protection, it will provide limited wall heights, ground reinforcement considerations, moderate cost, moderate design flexibility. So we have composite joist shown in the photograph on the right with composite floor decking. Then wood, it passes tests using multiple layers of sheathing, switching to steel plate or other metal cladding. Cedar joist with plywood sheathing fails across many assemblies. Infilling the wall with CMU or concrete does pass select tests. So this is a very This gives you very selective impact protection. It does provide the least cost. You're limited with wall height and span. It requires a more thorough study of assembly. Fire rate assemblies must be considered also. Concrete infill is counterproductive. So, in conclusion, the two best materials to use in your uh, storm shelters are going to be some sort of concrete system or composite system utilizing both steel and concrete. And then steel options, the composite steel deck bearing on a range of options, including beams, fabricated trusses, composite open web steel joist, steel roof deck over steel joist have also passed assembly tests as well. And steel can be exceptional for impact and protection. It does provide you with long span capabilities. It's a lighter assembly option in the seismic areas. The cost is moderate. It gives you the ultimate amount of flexibility, and it's an efficient combination of design factors. And solutions in steel design for these would also include AISC Design Guide 35, steel frame storm shelters, roof systems, steel deck, purlin systems, primary members, columns and exterior wall systems, exterior and then additional exterior wall systems, lateral force resistance systems and diaphragms, and then connection details. And then steel deck test per section, per section, 3.6. This is from Clemson University's perforated test in accordance with FEMA 361. The recommendations will include for steel deck gauge, span length, bearing length, lap connection, nestable only, connections at bearings, and screws. And then proprietary assemblies, systems that are engineered and tested to resist extreme wind and debris impact is defined by FEMA as FEMA 361 design and construction guidance for community safe rooms. And this will withstand wind speeds of 250 miles per hour, wind withstands wind uplift of 550 pounds per square foot, and meets FEMA 361 and impacting impact criteria impervious to water filtration. And the conclusions for this, steel has many options beyond meeting the scope of structural requirements for storm shelters. Other considerations may include long span options for large areas, composite joist for MEP, thin plate to maximize height, UL fire rated designs, acoustics to address ambient noise, and integrating seamless into the design and a community asset. So looking quickly at dormitories here, we have a few more minutes. A lot of times in dormitory construction for higher ed, we have seen a dovetail composite deck used. The functions of composite deck, composite action, composite deck profiles, and guidelines will be covered in this chapter quickly. Deeper composite deck typically comes in 4.5, 6, and 7.5 inch profiles. They typically work with lightweight, normal weight concrete options, 4,000 to 6,000 PSI strength concrete. And we also can close down the ends in the factory of this to eliminate an enclosure plate. You also can have clear spans up to 36 feet, but they will have to be shored at that point, temporary shoring to help the deck from deflecting. Dovetail composite deck comes in 2 and 3.5 inch deep profiles. As efficient spans up to 14 to 24 feet. It has a very thin slab look, and it is sometimes exposed as well. But when you're looking at STC and IIC numbers, typically we'll see layered drywall underneath it, as well as a flooring material of some kind, carpet and pad, wood for STC and IIC values. Dovetail composite deck is great for optimizing floor to floor height, keeping that floor to ceiling depth the same, as opposed to using a deeper structure. You're going to actually shorten the overall height of your building. System selection criteria, we'll look at floor span and depth ratios here, sound control, MEP integration, UL fire protection, vibration control, constructability, and aesthetics. So here we have the dovetail composite deck on light gauge bearing walls. Typically with this type of system, you can go up to 10 stories in height before the stud walls start to have a crippling problem, will start to deform. So this will this is for like a mid-low rise building in the 5 to 10 story range. With deep rib composite, it's been used in conjunction with upset wide flange beams, concrete blocks, wide flange beams, steel channels, existing wood beams, and steel plate beam systems. STC and IIC values for residential construction, including dormitories per IBC. The minimums are 50 STC and 50 IIC. And STC is measuring the barrier to transmission of sound between floors. IIC is impact on footsteps, and NRC measures sound absorption within a space. And I spoke of adding materials to create the STC and IIC values that you need in conjunction with the dovetail composite and the deep rib composite. There's a lot of inherent value with the concrete. So we're already at 51 for STC, but to achieve the IIC minimum of 50, you'll have to add a layer of gypsum board to the underneath side of it, perhaps some insulation behind that, and then on top of that, for the flooring, you'd have laminate or hardwood, or maybe a commercial carpet that's glued down. I mentioned a wedge anchor earlier. Various manufacturers have wedge anchors that can be used in conjunction with dovetail deck for suspending items from the floor assembly. UL rated numbers here for the dovetail composite deck. This is unprotected. This is just a deck and a concrete. It can range from 1 to 3 hours based on the concrete type and slab depth. So this is just the concrete. And we did condense this down quite a bit for today's presentation, these tables. The head of wall condition is also something that could be concerned about when you're using the dovetail composite on light gauge. The deck is offset where it bears, so the flutes are not continuous across the head of wall, and a plate is added between the two, and then concrete is poured on top of that. So there's 2 UL design details for that as well. And here's an example of the deck being offset, so those flutes are not continuous overhead of wall. And then, excuse me, a metal plate would be put in between the ends of those flutes of the deck to prevent concrete from going through the flutes. But it also helps to, it's part of the UL rated assembly for fire and smoke spread. Here's an example of temporary shoring used on dovetail composite deck on MSR, multi-story residential, or dormitory projects. We need to have this in place to keep the deck from deflecting from the weight of the concrete. And that's on spans 10 feet or greater. This will stay in place for 7 to 10 days. Within about 3 days, you can start with the floor above as long as this shoring is in place. Balconies can be incorporated into a dovetail composite deck, except they are formed and framed out separately from the deck. So the deck is not extending out and helping form this balcony shape. They're very shallow, 4 to 6 feet. A lot of times the reinforcement will go back many times per the cantilever length into the building to help cantilever to help support it. We would actually recommend using a separate attached balcony that's anchored to the building if you want something of greater size or span than these. And then looking at constructability for these systems, we're looking at weight savings and cost reductions, simplified erection and construction sequencing, reducing floor-to-floor heights, optimizing vertical spaces, and enhancing MEP integration and aesthetic appearance. And that is the conclusion, guys. I'll answer some of the questions here that I got, and then I will move on over to the other side, the holding space, and then answer some of them as well. One of the questions, is there an actual requirement to provide storm shelters in certain areas versus just guidelines, or is this more a matter of insurance requirements? I think it also, the part of the answer to this is it depends on the state. Some of the states in the Midwest, I believe, are starting to require these storm shelters in schools primarily. It's going to depend on your local jurisdiction. It also might, as you're pointing out, be a part of insurance requirements too. So I think insurance is not something I've heard of yet, but it would make sense that it would be. I can understand that as being something that owners should look into. I do know some states, Ohio was starting to look into this at one point, requiring them for schools, as well as I believe Oklahoma. Let's see. Enrico has asked, I understand we're focusing on learning centers, but have you done decking on industrial manufacturing facilities which have an interior environment? Yes, yes. Enrico, on industrial facilities, we'd recommend a G90 galvanization level also for those. A good paint resistive system, perhaps a 3-coat system. Sometimes we've seen a G120 deck specified as well for distilleries, in specifically the state of Kentucky for bourbon distilleries and such. So yes, an aggressive finish is needed in industrial manufacturing facilities. I know also in food processing plants, we've seen cellular deck specified and riveted cellular deck at that. So it's a smoother finish versus welded. In food manufacturing facilities, they have to clean the underside of the deck. But they want that smooth finish that's not fluted in that application. So yes, your deck finish and type, profile type, whether it's cellular or non, is also important to consider for industrial facilities. So, and